binomial probability examples. So take this problem right over here. If the probability that the Rangers will beat the Islanders will beat the Rangers in a game is 61%. So probability Rangers Islanders beat Rangers, right? Probability Islanders beat Rangers is equal to 0.61. So probability that the Islanders lose to the Rangers is equal to 1 minus 0.61, because either you're going to beat the Rangers or you're going to lose to the Rangers, right? I mean, you can't do both. So either you're going to beat the Rangers or you're going to lose to the Rangers. So in that case, that would be 0.39, because notice, you're either going to win or you're going to lose. So those two things have to add up to 1. So the question is, what's the probability that the Islanders will win exactly 1 out of 6 games? Probabilities, Islanders win 1 of 6 games. Okay, so if they win 1, they're going to lose 5. So you got 6 games, can win any one of those games. Probability that they win is 0.61 to the first power. But you know that they're going to lose 5 of the games. So that's 0.39 to the 5th power. And again, we're just doing that on our calculator. Once we write it out, we're going to do the rest of it on the calculator. So we're going to go in here and we're going to do, remember, you get the combinations by going to functions, CR, do 6, comma 1. I'm going to go back to the main. I'm going to close that. I'm going to do times. I'm going to do 0.61. And we can raise that to the first power. You really wouldn't need to because it's just the first power, but I'll do it anyway just so you see the formula. 0.39 to the 5th power. So we get roughly 0.03302205683, whatever that is. I mean, that's a decimal, right? So roughly 3%. So let's go back and so round to the nearest thousandth. So that's the 3 decimal places. So if we go here and we do 0.033, that's the nearest thousandths. Remember, tens, hundreds, thousandths, and we should get the right answer on that. And then it'll show you how to do it. Let me show you one more problem. Let's take this one right here. And Mr. and Mrs. Doran have a genetic history. The probability of a child being born to them with a certain trait is 3/4. Probability of having this trait is equal to 3/4. So the probability of not having the trait, because either you have the trait or not, is 1/4. Because again, it has to add up to 1. Remember that those 2 traits have to add up to 1. Either you got a success or you got a failure. If they have 3 children, what's the probability that exactly 3 of the 3 children will have the trait? So 3 kids, choose 3. They all have the trait, so that's 3/4 to the 3rd power, and 1/4 to the 0 power, because none of the kids don't have the trait. They all have the trait on there. Again, if I go into Desmos and I get my new thing and I'm going to go to function, order doesn't matter. So we use combinations, 3, choose 3 times I'm going to use 0.75 because that's 3/4 to the third times 0.25 because that's 1/4. Not to the 0, or not to the 1, to the 0 power. And we end up with that. If you wanted to get a fraction, you could get a fraction right here. You can see how this thing pulls it to a fraction. It doesn't matter to me. It doesn't matter to delta math what you get, but we get roughly 0.421875. Now let's answer whatever delta math asks us. Round to the nearest thousandths. Again, that's 3 decimal places. So we're going to do 0.422 because we're going to round up on that one. And we get the right answer there. Hopefully that helps. If you need more help, let me know, and I'd be happy to give you more assistance.